Well, hello, hello. Sorry for the long intro on that. I got a call from my wife right as I hit the stream button, and so I had to take that real quick. Anyway, hello, hello, and welcome back. I'm AJ O'Neill, and I will be your instructor for today's Beyond Code Live. And we are going on part 3 here of the switching between time zones and JavaScript. And before I jump into it, if at any point you have that aha moment where something clicks for you, you find this valuable, please give it a thumbs up and like and subscribe and all that if you want to. So a smaller recap, because if you kind of part 2, you could have just watched that alone and skipped part 1. This part 3 we're not gonna go over as much, but basically, the problem that we solved last time was that we can get from UTC to a time zone. That's not too hard. There's an international object, INTL, that allows you to format times. The problem is that the way that it formats the time is not parsable by the date object, so it's basically incompatible with itself. In a good program, the output of the program should be able to feed into the input of the program, and the input of the program should, there should be symmetry between. Obviously, you don't always want the inputs and outputs to be the same. You want formatting options, but there should be a formatting option that the output of the program and the input of the program are compatible with each other. We don't have that in JavaScript. Then we have another problem is that the date object knows time offsets, but the international object doesn't know time offsets. So the date object doesn't know time zones, but it knows offsets. The international object knows time zones, but it doesn't know offsets. And you basically just have to calculate these by hand, which is not too hard, and we solved that problem. Now, the next problem is not too bad if you are looking at the current time and that's all you care about. Then you can get that ends up being number 3 here. But the problem is that time changes over time. So what time it is today in 24 hours may not be the time that it is tomorrow, because time isn't mathematical, it's based on politics. And so the problem that we have to solve for is during a daylight savings time change, there is a window of time in which the time is different. So if we were to calculate a future time, say we were to calculate November 7th, I think is when the time changes. If we were to calculate November 7th, the offset is different on November 7th than it is on November 6th. And specifically I'm going to go down here. So for those of you that have not followed along, or that were following along rather, this is the part to start tuning in. There's no representation. No, there are 2 representations of 1:15 a.m. on November 7th this year, which is the first one happens. The way to write it, the only way to distinguish it that I'm aware of, is to use a ISO time with offset. If we use an ISO time with offset, then we would have 1:15 a.m. minus 400, but then in the future, we would actually get 1:15 a.m. minus 500. And then we would be skipping. No, we're not skipping. That's in the opposite direction. And then when we have 2:15 a.m., it would be at minus 500. It would not be a valid time to have 2:15 minus 400 because the time switches at this hour. So this hour locally repeats twice. 1:15 a.m. will happen twice. So because of that, what would happen if we just did the calculation is of the looking at the time difference between our target time zone, say New York, and the UTC time. If we get the UTC time, format it as New York time, and then calculate the difference, which is what we've done in the code here, up at this part where I think it was get offset. I think this is the area where we're doing that. If we do that calculation, then we end up being off by 1 hour during the time zone change. So we actually have to guess and check. We have to guess what we think the time will be, and then we have to check to see if our guess is correct, which it will be all of the time except for twice a year if you are in the American New York time zone, and potentially other times, but different times of the year, even if twice the year, different times of the year in other time zones. So there's not a good generic solution for this. There's not a mechanism that exists in JavaScript to solve this problem. We have to do the guess and check. So that's where we were up to last time. So I'm going to take this code here, and if you could watch the last video, it was kind of long. I don't think this one would be as long. We got from UTC time to time zone. Basically uses a new date object, passes it in a bunch of generic options. There's nothing too special about this except for there's an issue with 12-hour. And then we have to account for a couple of oddities. That's what this whole switch statement is here. We're just accounting for a couple of oddities. We're going to ignore, we format it, but not to a string. We format it to an array of parts of the string. And I covered that last time. But there's a type and a value to each part that comes in the array, and the type is something like month, day, year, minute, hour, second. I put those in the wrong order, but whatever. And then there's a value, which is going to be something like 5 or 26, etc. Now, there's also a couple of extra things that are more metadata-y-ish. For example, literal, so it will show where slashes are supposed to go and according to which language the time is represented in and which locale. So for example, in America, we do the stupid thing where we have Middle Indian times where we do month and then day and then year. So we're not doing greatest to least or least to greatest. In Great Britain, they do the same thing, which is to have day, month, year, where at least you're going in a direction that makes sense and not omnidirectional, weird directions. Anyway, so this method gives us the items in the wrong order, but it gives them with the correct name. So for any zone, we can get all of the values that we need. We just have to tweak a couple. So we ignore the literals. We parse everything except for the time zone name we keep as a string. The month, we need to subtract 1 because months are 0 indexed. The hour, we need to mod 24 because hours are 1 indexed and go to 24 being equal to 0 because And there's an option to change that, but it doesn't work in all browsers, so we just do it by hand. Fractional second, I don't know why they didn't use milliseconds. I talked about this last time. Anyway, so we go through, we get an object. Let me just go ahead and show you what it looks like. Do I need to do all the padding and stuff here? I think I do. Yeah, so I'm just gonna copy this whole thing. Yeah, I'll just copy the whole thing. And then I'll show you what it looks like, and then we'll get started from there. So just kind of a recap. Oh, that's not what we wanted there. Is it? Oh, skipped a comment. Okay. So, yeah, I'm gonna run this. I'll show you what this object looks like because I printed out right here. So we get an object that looks like this. Before it was an array, and the array was type day value 27, type hour value 0, and well, actually it was value 24, and so on and so forth, and it goes on. We got the time zone name, good. So this is where we run into a problem, is when we hit well, actually this time it is working because we set, what are we at on the hour? 4 hour, okay. So the hour after the whole time zone change is complete, we get the values that we expect. So at 4:15 a.m. we get minus 400, but we have a problem in that if I run this again, and so much of the code is already here, so I apologize for that, but it is what it is. If we run this again and we change it to be 2:15 a.m., we get some daylight savings confusion. So the very last thing that we get output here is daylight savings confusion. And what the problem is that I set the target, the date that I'm trying to get in the American New York time zone is November 7th. Oh, it's missing something there. Let me check on that real quick. Actually, let me go back here. I think I know what I did wrong on that. I think I was intending to replace T. Yeah. Should have replaced the letter T with a space and replaced the letter Z with nothingness. That's what this was supposed to be. So if I do that, I'm going to update that. Okay. Whoops, that's all gone. Okay, bring it back. Here we go. So the output. I gotta change this one more time. Where is my time that I want to test? And I should probably take this out of the browser and start putting it in my IDE, because when I first started, just toying around with this, doing all this stuff in the console was fine, but now it's getting to the point where I'm not getting the same returns on doing it that way. But anyway, okay, this is what I want to demonstrate. So instead of getting, I think it got the offset correct, but it got the hour wrong. So we're trying to get 2:15 a.m. And according to what I have in the comments here of me thinking about it with my brain, because one mistake that I often make that I encourage you not to make, which I've talked about in the last episode, is you want to make sure that you understand in your own head that you can write out by hand or in comments or in pseudocode what the result actually is supposed to be, not just throw code at a problem. I do this all the time where I just start coding without actually knowing what the result is and just doing kind of guess and check, but guess and check not because I have no other option, but because I'm being lazy and the wrong kind of lazy, right? So here, it looks like the offset is correct for that time, but the time itself is wrong. So we have to correct for this, and we're going to have to write another test case that's going to test in the other way, and then I'll probably actually make a test file. But 2:15 a.m. should be in the minus 500 offset, and it's not actually 500. That's 5 hours and 0 minutes is what that actually stands for. It's 0500 or however you say it. But what we get here is wrong. And so this is where the guess and check failed. I put in a target time zone that I wanted. I said format this as New York time, and it gave me the wrong time because it gave me UTC, the UTC version of that time. And so I say, okay, take the difference, take the offset, and then subtract the offset from the number, or add the offset to the number. So subtract the offset from the number so that we push the UTC time forward. So I gave it UTC time here. That's obviously not the same time that it is in New York. So then we changed it. We added 4 to this so that this ended up being, let me see if I can actually show that. Oh, here's a good one where it shows. This is what we're kind of doing here. That one's the Colombo time. Anyway, sorry. This is a difficult problem, and it's definitely difficult to pick up on a part 3 of. But that's why I'm doing the recap. So I got everything fresh in my own brain. But now what we need to do. Oh, okay. So sorry. We've changed the offset, but what we need to do is when we change the offset, the time is actually changed, like I mentioned before. And so now we need to figure out how do we correct the New York time without breaking the UTC time. And I think, well, this is the tricky bit. Where are we dealing with? So basically, if the original time, the UTC date, we give something as a UTC date, we shift it to be in our target time zone, but our UTC date, the hours that we give originally, that is our target, is what we should end up with as our hours. That's the whole point of this, is that we're trying to shift the time in the wrong direction to account for the fact that we don't have we only have a one-way function, and we need to make it a two-way function. So if my original target time was 2 a.m., then the result time that I should get formatted in the time zone should be 2 a.m. That's the thing here. So if that is the case, if the time and the minute, because there are time zones that are off by 30 minutes, not by an hour, if the time and the minute are the same, then our target time is the same as expected. Otherwise, we have some daylight savings confusion, and we have to figure out how to solve this problem. And I think what the way that we're going to go about this, I'm going to have to console.log some more stuff here. But I think the way that we're going to go about this is which offset was correct. Let me scroll back up here. And I don't need to copy all this code every time, because all that I need to worry about right now is I don't need to worry about any of this stuff anymore. So let me just get rid of that. And I don't need to worry about any of this stuff. That's all stuff that works. This is the part that doesn't work yet, is just this bit. So let me copy that out, run it again, and then go back here. So what I want to do, which of these is correct? It looks like the updated time has the correct offset. That makes sense. So our first attempt, which we're calling TZ D2, and D2 is not because it's the second one, but it's because it's like a date object, but not a date object, because we have to make our own bespoke date object for this to work. So we've got TZ D2, which is the adjusted time zone. Its offset is not going to be correct because it is going to be basically it's not aware that the time shift has happened. When we find out that we change the time, this is our mod date, so it's the UTC date, but we're modifying it by the offset and then checking again to see if we get the right time, or not. We're not checking to see if we're creating the time by the offset. Anyway, this one is not aware of a daylight savings time. This one is aware of a daylight savings time in terms of the offset that it gets. It knows that the offset is off, but that is different is correct, but the hours are wrong. Sorry, this is so... Ugh. It's a hard problem. I wish I knew how to explain it well, but I'm learning how to do it as I go, because I don't natively think in time shifts in my brain. It's not what my brain is optimized for. I mean, I've got the times tables memorized, but I don't have the world time zone map memorized. And I imagine you don't either. Anyway, what we need to do, this is correct, this is incorrect. So I think what we do is we take a difference of the correct offset minus the incorrect offset. And then I think that we want to take hours and minutes out of this. So I think that we need to do math.absolute value, because even if this is negative, at this point we're just interested in the whole value of it. So we want to take that divided by the number of 60 minutes. So whatever the offset is, we want to divide by 60 minutes in hopes that we get hours. And let's see, what else do we need to do here? I think we need to round this. We need to round it. Or do we need to floor it? I think we need to floor this one. I did this before somewhere. Let me go check and see what I did there. Did I round or did I floor? Yes. Okay, floor. Because we're making it absolute, so we can floor it. Because if we get an hour, if the daylight savings time is not an even hour, if it's half an hour or an hour and a quarter or something like that, which I don't think any hour and a quarter exists today, but there are time zones in which hour and a quarter did exist historically. Anyway, we just need to make sure that we are getting the whole value of the hour, because then we're going to take math.abs and take, oh, no, this needs to be the diff. All right. Of the diff, and then we're going to mod that with 60. And so if the time zone change is not a perfect hour, if it is an hour and a half or 30 minutes or an hour and a quarter or whatever, we're going to get that value. So now that we know the hours and minutes that we need to change something by, what we can do is take our tzd3.hour and then add the hour to it times, let's see, what's the easiest way to do this? The negative symbol. So that should give us the sign. Let's see, let's do var s for sign. I think sign is a reserved word. No, it's not. Okay, let's try this though. Is that right? That will give us the sign. So we want to, do we want to add or subtract? Let me think about this for a second. What we're going to get from this, the greater offset minus the smaller offset gives us a negative number, but we need to go forward. So minus a negative number would be adding, which is the direction that we need to move, because that's the direction that we're off. So if we do that for both of these, that I think is going to work for us. And maybe rather than getting the sign, the better thing would be to check if diff is greater than or less than, and then do a plus or a minus. But I'm going to go with that for now so that I can get to the point of checking this. So if I just run this again as is, oh, unexpected identifier. I think it might be sign. Where is it saying unexpected identifier? Let me see. Var diff, oh, equals. That's why it's unexpected. I left out the equals there. Let's put in the equals. Okay, so now this may be correct. Is this correct now? Our hour is, that does not look correct to me. So let's see. What do we need to change? Because we're going to need to format this again. I'm a little confused because I actually expect this to be correct. At this point. Okay. So I'm printing out offsets 1 and 2. All right, let's see. What do we need to print out? Daylight savings confusion. What was the target? That was the target that we're trying to get to. And what did we actually get instead? And let's see. let's see what we get here. Console.log. I want to put an hour and minute as updated offset, or rather, that doesn't even make sense to say. That's okay. What do we got? Updated 1 and 0. And what's the sign here? Let's put the sign in here as well. All right, so we should have -1. Oh gosh, this could be horrendous. Let me think about this for a second. I think the problem that we could run into here. Oh. Okay, if it's off by an hour and a half. No, that should work. Okay, that should work. This is going to be one of those things where a bug report will let me know, because I don't have to worry about it in the United States, at least not now, and probably not for the next 10 years. But somebody somewhere might be in one of these rare half-hour time zone type situations. Okay, anyway, what am I looking at? What I'm wondering is, if this is correct, why... Let me look at my code. I probably just didn't do something right. Oh, that's why. I need to do minus equals, and minus equals here. That should correct the problem. Okay. I wasn't actually assigning the value after I created it. So that actually is my target time. So this is, I would say this passes test. So I'm going to take this bit that I modified, I'm going to copy it, I'm going to paste it over here, and I'm going to save. And then I need to try it a few more times. I think it was up to here-ish, I think. Is that right? That looks about right. Okay. I'll just look at the diff between these to make sure. Let me look at the revisions here. Adding that somewhere that it didn't need to be. Got it. Okay, so I'll fix that in a minute. Maybe. Or maybe I won't. Maybe I'll just leave it. So we need to test this for the next time. So we need that should be, now we need to make sure that it doesn't mess up anything else. Yeah, that should be right in this direction at least. I'm really scared that when we go in the opposite direction, we're going to have another problem, and it's going to be difficult to distinguish between the two. But for right now, the 215 is working, so I need to check that the 315 is working as well. So let's change this to 315. And unfortunately, we are basically missing an hour there. We have to make a choice of how the algorithm should work. And in this case, what I end up saying is that because we want, no, this is right. We want it to be 215, and there is only one 215. It is just across the time zone boundary, or daylight savings time boundary. All right, now we have 3:15 a.m. in New York on November 7th. From UTC time zone is not defined. Of course not. Of course not. Because for some strange reason, when you do Command K nowadays in the DevTools, it clears out all temporary variables and functions just as if you had reloaded the page. I guess that could be a blessing or a curse. All right, daylight savings confusion. Our target was 2:15. We got 2:15. That's good. Now let's change our target to be 3:15. And does it still work? All right, it looks good. So this is working when we are falling back. Now we have to check and see, does it work when we spring forward? So I need to go look at what the politicians tell us about when it will next be daylight savings time. So we want to pick something that's in the future. I guess it'd be okay to pick something in the past. I'll pick something in the past. That'll be fine. It should work for future or past equally well. But you wouldn't want to go too far future or too far past, maybe. I don't know. Basically, my thought on this is, why would you do this in the first place? Because you want to, probably because you want to know when something happened, or you want to schedule an event. If you're scheduling an event more than a year in advance, I would say that you should have some routine that stores the time with the time zone, such as America/New York, and the target time, and then does a recalculation about 6 months before the event happens. Because if you don't do that, there is the possibility that the daylight savings time or time zone or something else has changed and needs to be recalculated. Of course, your server would have to be up to date as well, because your server would have to get, or whatever is doing the calculations, the browser, the operating system would have to be up to date so that the browser can read the system's belief about times and know. Because basically what happens is somebody in a position of control over a nation's time puts a proposal forward, it goes to a vote, goes through legislature, and it'll probably be a couple of years typically between the time that people are talking about it and the time that it actually goes into effect. And before it goes into effect, it will go into a time zone file that is part of operating system and phone and device updates. And it will indicate that at such and such a year on such and such a day, the time zone policy will change to this new time zone policy and this new daylight savings time policy. And so it is highly, highly, highly unlikely that that would ever be fast enough to happen within 6 months. Because when it's being talked about, it's going to be staged in a Git repository or maybe just a mailing list somewhere as a change to one of those time zone files. And when it actually gets ratified and voted on and decided, there's most likely going to be a year between the time that it's finally decided and when it actually is implemented for the first time. So but anyway, that's why I'm picking these times. Is worst case scenario, you could have a time change within a year. Okay. I don't know if I want to do this anymore. This might have been a bad project to embark on. I thought, it's not going to be so bad. Just going to do some addition and subtraction. It's just all the little things you have to think about. Anyway, so March 14th, 1 a.m., 2 a.m., 3 a.m., 4 a.m. That's what we need to check. That'll be really interesting to see what happens with that. So I'm going to say here's the other problem that we're going to have is going to be, what time is it in, what was it, March 14th at 1 a.m. and then 2 a.m. and then 3 a.m. and 4 a.m. So March 14th, we're not going to be in daylight savings time. We're going to be entering daylight savings time. So we're going to be an hour behind, which means that 5 hours behind in New York, meaning that if it is 1 a.m. in New York, it is 6 a.m. at UTC, and the representation of this would be -5. That makes sense. Then we're going to have, I don't know why I've got that listed there twice. I'm sure there's a good reason. Oh, it's just because this is the next natural progression, is that time will happen. Let's see. Oh, and I need to update all of these. Whoops, nope, just from there to there, from there to there, from there to there. Okay, so if we want that time, what was that time about? Let me check my comments here. Oh, that's a target time. The target time would be equal to this time. Got it. So if our target time is 6 a.m. locally? No. What am I saying here? No, this is not our target time. This is our source time. It's UTC. Okay, so what is our source time? Our source time is incrementing there. So then 2 a.m. does not happen in this case, I think. Let me go check. 2 a.m. goes forward to 3 a.m. So 2 a.m. actually doesn't happen. So what we could expect here would be undefined, because we'd actually go to 3 minus 4. So there is no target time of 2:15 a.m. But I'm going to try putting that in anyway, because we need to know what happens, because someone might schedule an event for 2:15 a.m. and it needs, I guess it would happen at 3:15 a.m. I don't know. What happens when you have emails scheduled to go out? Well, you don't schedule emails respective to. Well, you could. Because if I'm targeting my customers who I know are in New York, and I want to send out emails before they wake up, and I send them out at 2 a.m., I don't want them to send out again at 3 a.m. I don't want people to get twice as many emails during daylight savings jumps. So that we need to have a definite time of things that happen. And what about things that happen once every hour? What do you do? I guess you have to monotonically increment the hour. These are just questions that break my brain. I'm going to guess that time doesn't exist. So I'm going to guess, is it 8? And then this is 8 again. Yeah. So wait. You know where I need to be doing this? I need to be doing this where I can see the whole thing wideways. Let me go like that. Yeah. Okay, that's a little bit helpful. Let me zoom that out so I can see this all at once. So we want to know what time is 1 a.m., 2 a.m., 3 a.m. I think if we get those 3 times right, then we should be good. But I'm going to put in here 4 a.m. as well, just to make sure I've covered my bases and my boundary cases. Okay, there we go. That's a lot easier. So it's going to go from 6 UTC to 7 UTC. It's going to stay 8 UTC twice because that time doesn't actually happen in reality. We're going to jump to 3:15 minus 4, which is going to be equal to, wait a minute, that doesn't make sense. Are we saying these two are the same? 7 is the same as this, 8 is the same as, no? Oh gosh. 7 is the same as 3 minus 4. What would we call that time that doesn't exist? Could it be -5? Could we represent it that way? No, because it doesn't exist. It literally doesn't happen. is not possible. Let me think about this. Okay, 1 a.m. minus 5 hours, UTC is 6. That's correct. So let's get rid of this other bogus garbage, because that's not real. 2 a.m. does not have a representation. It would be 7 a.m. if it did, but it doesn't have a representation because it doesn't exist. It is the same as it's an alias for 3 a.m. 2 a.m. is an alias for 3 a.m. So then this would be like that, counting in UTC time, and then we would count this exactly the same because these two times would have only one representation, 2:15 a.m. and 3:15 a.m. on that day. Whoops, which I need to go ahead and copy all of these things here so that I actually have a good representation of what they are. And I'm looking at the right thing. All of them are what they are. That was stupid to say. Okay, now we have 4 a.m. would now be, okay, so this UTC time is the same as this offset time. This UTC time is the same as this offset time. This time doesn't actually exist, so both of these times are the same with the same offset. There is no way to represent this. Okay, so this is where we're going to come into a problem with this particular issue. If we're jumping forward in time, this is where the problem I was thinking would comes in. I think if the sign, but this could be different in time zones that are plus versus time zones that are minus, maybe? No, it shouldn't make a difference because moving forward in the negative is a smaller negative, which would mean that we get a negative number when we subtract the one from the other. Moving forward in positive time is a greater positive, which means that we get a negative number when we subtract the one from the other. Okay, so that should be correct. So I think if the sign is positive, then it is okay that the number is incorrect because that time doesn't exist and we want to represent the official time, not the imaginary time. So that's what's going to be problematic here. So let's go ahead. I'm going to start with 1 a.m. and I need to do a whole new set of dates here. So we're going to, and we're going to need to do a few more. Let's see, this is test for ending daylight savings. This is test for starting daylight savings. And again, we'll put this into real tests. I am getting diminishing returns working in the console like this, but I'm kind of in the mode of what I'm doing, and so I don't want to change, and I don't think that the diminishing returns are really that bad. Unless I lose my work, and then that would be annoying. So let me go ahead and save all of this real quick. Just take all that big chunk there, bring it over here, save it. Oops, over here. Whew, baba. That's all this hubbubaloo. Wait, what did I take? That whole bit. You know what? I don't like the way that I did that. I'm gonna do this differently. Well, we'll mix it up later. This is testing for ending daylight. We probably want to test for starting it first. Ending is actually simpler. Well, maybe. Let's see, works great. It's for, we don't need this one. Enter daylight savings confusion. There we go, yeah. So these should work, and these should require modification. All right, good enough, good enough. So let's take the 1 a.m. I expect that this is not going to give us the confusion message. I expect that this is going to give this time is same as expected message, because at 1 a.m. nothing has changed yet. It doesn't change until the 2 a.m. Target time is same as expected. Okay, good. So that matches my expectations. I'm happy. Now let's go to the 4 a.m. and see. This one I'm not so sure about. Because technically these two times are the same. So by the time it gets to 4 a.m., I think it may have jumped. So I think, here's what I'm going to try. 5 a.m., I'm pretty darn certain is going to be no problem. So let's try 5 a.m. Target time is same as expected. Good. Good. All right, so just these are sanity checks. We know that this is going to be just fine. But sanity check to make sure. Okay, now 4 might be just fine. I can't articulate why I think it might not be, other than that this time only happens once. And I expect there to be 2 times when the time is calculated that the offset doesn't match right. And since this is actually the same time, then I expect this might be the time that it is different. Okay, daylight savings confusion, indeed. Okay, so there we are. And then, so this one actually goes down in, whoops, with these, in that case. And I just want to check to see, do I get the daylight savings confusion at 2 a.m.? Yes, I do. And do I get it at 3 a.m.? I expect that all 3 of these are going to be messed up. And yes, I do. Okay, great. So at least my boundary, my assumptions about my boundary condition, my intuition, and a little bit of actual math are correct. Let's see. So let me run this again. I'm actually going to move this comment up here so I can just replace the comment that I had before. Again, all of this stuff will move into test conditions. But because I really do need to be able to look at the debug output here and kind of reason my way around it, I'm fine with this as is. All right. So what is wrong about this? The target was 2:15 a.m. and the result was 2:15 a.m. So why is this wrong? I'm not clear actually on why that says there's daylight savings confusion. Let's go take a peek at this a little closer. All right. And I think I want to, can I get rid of some of this stuff? I think I already did for the most part. Okay, I'm just going to comment out all these. I don't need them. They're not helpful right now. They're going to be part of a test, but they're not part of this. Yeah, I can just comment out this whole block here. Okay. And really, this time doesn't even matter. I'm going to go ahead and just forget about it. Okay. So, 2:15 a.m. The current check says if the hour and the minute are correct, then the target time is what is expected. it should not be possible for 2 a.m. to show up correctly. So else, daylight savings time confusion. And then let's say target, and then let's say console.log. Oops, or we could call this expected. And then actual, that's pretty common for debugging things. So the actual that we get is TZD3. I could say offset delta. I don't need to repeat this again. This could be offsets and offset delta. That makes sense. And then I think it would be fair to actually log this here and then log this for more information, full object, and then we don't really need to log that there. Okay, I think that's feels right. So the expected and the actual, okay, good. Good, good, good. Now, if the offset is positive, this is okay. Right? But is the offset correct here? Yeah, the offset is correct. So in this case, we actually got, it looks wrong, but it's right. So how can we detect that it's right even though it looks wrong? Because we asked for 2:15 a.m. 2:15 a.m. is wrong itself. So it is correct that we get back 3:15 a.m. So how can we define that? I'm not sure. I'm not sure. I'm going to go on to the next one because I think that's going to help me to understand this better. So what I expect here is I expect this one, actually, I kind of just expect it to pass and say, yeah, this is right. But what do we get instead? Expected and actual. And then the delta. Okay. So then if we've got that delta, then we should have adjusted here. This is where it gets tricky. Okay, so the adjusted is correct. Oh, so how do we detect when it is the hour that doesn't exist? That's the question that's difficult to answer. Okay, let's take a look at the adjusted of the previous one. Because I think what's going to happen is it's going to end up being wrong. This is the tricky bit right here. Because, well, I'm going to double check this one, but I bet this one comes out just fine. So, oh wait, this was supposed to be yeah, that's 4:15 a.m. I bet this one comes out just fine. Yep, that comes out correct. So, our current logic works except for one case. It does not work for the time that doesn't exist. And the question that I have is, how do we detect the time that doesn't exist? It's an invalid time. It would be fair to say, I could document in the library, if you put in a time that doesn't exist, the result is undefined. For now, open an issue, if this is a problem for you. But I would like to handle it. I just don't know what to do. Because what will end up happening is that it will get adjusted and it'll be wrong. How do I detect that programmatically? It feels like I got to walk it, meaning I could check an hour before, check an hour after. But I don't like that. I don't like that approach. That might be the only approach. It might just be the guess and check, walk it. So 1:15 a.m. 2:15 a.m. How could I know? How could I know? The thing that comes to mind is checking the hour prior. I'm going to take what I've got right now and I'm going to go ahead and save it again. I almost should have two files for this. This bit here is kind of my test file, and that other bit is the other bit. Yeah. What's the worst that could happen if I don't fix it? How wrong is the time? Is it taking us forwards in time or backwards in time? It takes us backwards in time. Because 2:15 minus 4 is the same as 1:15 minus 5. So that is bad because we get repeat events. How would I know? Is there a way to programmatically know that is relatively simple to detect? I could subtract an hour. And then if subtracting an hour gives me the same time, then I know that I'm skipping. Well, that only works if the difference... So this is where this becomes a problem. That works for jumps that are hour jumps. But I don't know that that would work for an hour and a half jump. Because in the United States, the jump is an hour. I think, since I don't know what to do, I think the appropriate thing to say in this situation is just document if an invalid time is entered. Let's see here. Expected, actual. The actual was correct. Dang it. Well, it's an invalid time. It is undefined. Who am I? Who am I to define what should happen in this case? I think it's okay to say that is undefined behavior. And if I need to make a breaking change, then I just change the library to v2. I'm going to go with that's acceptable in this case. I think that is acceptable in this case. Oh, I didn't notice I got a comment earlier. I'm not actually sure how to say your name. I think it's Fate, or it might be Fate. Fate series. Oh, okay, yeah, that looks like 2 English words, pseudonym there. Thank you. Thank you. It says, your passion towards coding is really admirable. Please keep up the good content. Thank you. I appreciate that. That means a lot. Whew. All right, I think at this point, the correct thing for me to do is actually to go take a walk, because I'm at a point where I think that the right thing to do is nothing, just to document that there is an exceptional case. My brain is a little bit bendy right now because this is a hard problem to solve, and it doesn't have a good solution because it's not a solvable problem. It's not something to do with mathematics. It is something to do with politics, and politics are a human emotional problem, not a hard science problem. I mean, it is a problem with mathematics in a degree, in that it is possible to deterministically find what this is. But here's the thing. By the time that this is a real problem for me or someone that might be using the library, I think that's that the temporal object might, in JavaScript, might actually get to the point of being standardized. So let me go back here real quick. There is a solution coming for this, which is the temporal object. So it'll probably be a few years before it's standardized and has polyfills, et cetera, et cetera. But this has date times. Well, I don't know. I think part of the reason, yeah, zoned date time. There we go. Right there. So you know what I should have done? What I should have done before I embarked on this at all is I should have checked to see if there was a temporal polyfill already. That's what I should have done. That would have been smart. I don't even want to look. I don't even want to know. It's just going to hurt my feelings. There probably is. I'm probably an idiot. Yeah, of course there is. Darn it. Let's see how. Oh gosh. Okay. No. That's a straight no. 4 megabytes is a straight no. Okay, I feel justified now. That's what I was afraid of anyway. Okay, so I'm going to pause and I'm going to take a walk, and then I'll come back to this with a part 4. And the part 4 is basically going to be, okay, we accepted there's some limitations. I need to get my test together. I need to document the edge cases that are don't have a good desirable solution. And then I can publish this to NPM or whatever and be done with it. But yeah, I'm going to take a break. I'm going to take a walk. So thanks for tuning in, and I will see you next time on Time Zones and JavaScript Part 4. Adios.